Okay, so here we are in Chapter 4. We're in Section 4.1. We're talking about solving systems of equations. So Chapter 4 is going to be talking about systems of equations because Chapter 3, we're kind of leading from Chapter 3. Chapter 3 told us about equations and how an equation tell us, kind of describe a lot of information that's on a line. So for example, we could call this our supply line, and we could call this green line our demand line, and we could have a line that's described by y equals mx plus b, and have that with a certain number for m, slope, and a certain number for b, y-intercept. We can say that this description, y equals mx plus b, with specific numbers for m and b, can describe our supply line, and different numbers would describe our demand line. So that's what was in chapter 3. We talked about just simply creating a line from a bunch of data points, and especially 2 points maybe, and that would make a line. And there were other ways that we did that we created that line. Now, if we're talking about a system of equations, that means that we have 2 equations and 2 unknowns. System of equations means 2 equations, 2 unknowns. We're going to be able to solve systems of equations. By solving the system of equations, we're going to come to one point that says this point is on both lines. And that's what solving means. You can find an x value and a y value, and that x value and y value are going to specifically describe that point there that makes both of these lines happy. Or is on both lines, I guess. Makes both lines happy, that point is on both lines. So this is kind of a real life situation here, that if we've got, let's say Apple's selling iPods, and they want to go out and they want to say, what should our price be? And what should our price be, and how many are we going to sell? Because we need to be able to tell our factory how many to make. Because we can't just go out and say, make 10, make 100, make 1,000, make 1,000,000. I don't know. I really don't know. And we can't also just say, maybe $10, maybe $15, maybe $50. Who knows? We don't know what that is. So what they do is they go out and they ask people, and they talk about the demand line. They would ask people, you know what? If our price were here, then how many would buy, like an Apple iPod Touch 32 gig? And they'd say this price is right here. It's just an arbitrary number right here. This price is right here, and they'd say, 50 people would make it. So 50 people here would say, if you had the price at $1,000, then 50 people would buy it. All right. Well, if the price were at let's say $500, how many people would buy it? Oh, well, there would be a lot more people here. So they would say, for the demand line, they'd talk to, again, people. They'd bring people into a room, and they'd say, if the price were $500, how many people would buy it? Oh, be maybe 100 people. So you get these 2 points, and to be honest with you, they would get thousands of points, and they would say, you know what, if the price were here, and there'd be something like this. These dots would approximate what people would vote. If we had $1,000, how many people would buy it? 50 people. If we had the price at $500, how many people would buy it? 100 people. So they get this big line, and they say, well, let's approximate our line, and they would do the same thing that we did. Find an approximation. They'd probably use powerful software or even Excel to get that line. Now, on the other hand, they would also say, what happens if the price were $1,000? From their standpoint, from the supply standpoint, they would say, if the price were $1,000, boy, I tell you what, we'll sell a whole bunch of them. We'll sell a bunch of them. We'll sell a lot of them. If the price were $500, yeah, you know what? I think we probably wouldn't sell that many. We wouldn't want to sell that many because we just wouldn't make that much money. So they would have their supply line kind of go like this, and they would get some data points, and they would get that line that's purple. I don't have a purple pen, otherwise I'd use purple. But they would use the red data points. They would say, yeah, for all these points here, price goes up, things like that. So here's their supply line where Apple says, we'll supply it to you. Here's the demand line where people says, we'll buy it. And where those 2 lines meet, right in there, is going to be that happy medium, that happy point where the supply is happy, where if we're selling it for $750, a whole bunch of people would buy it, and the number of units that would be made by Apple is exactly the same as the number of units that would be bought by people, and that's on the demand line. So there's where kind of a real life situation where people might have an application for supply and demand and a system of equations and solving that system of equations. So before we get to figuring out how to do that, we need to kind of find that if we find this point that's in red, we need to make sure that it's on both the supply line and the demand line, both on the purple line and the green line. Right now it's supply and demand, but it could be anything that we choose in our applications. So we need to make sure that that point is on both of those lines. And how do we do that? We really need to we need to confirm that that point satisfies both of the lines. So here's a line here in red, and there's also a line in green. And we'll say, you know what, here's my point. Does that point satisfy both lines? So we'll go up to the red line. We'll say, well, x plus y equals 4. Here's my x, and here's my y. Does x plus y equal 4? 3 plus 1 equals 4? Yep, sure enough. You could say that x plus y equals 4, and this is probably the long way to do it. 3 plus 1 equals 4 with a question mark, and sure enough it does. So it satisfies the red line. Does that point satisfy the green line? Well, here's my green line, negative 2x plus y equals negative 5, and we have to substitute in our x and y values. X is 3, so anytime we see an x, we substitute in x equals 3. Negative 2 times 3 plus y is 1, equals, with a question mark, negative 5. This green one might be our supply line. We've got to make sure that it satisfies that one as well. Negative 6 plus 1 equals, with a question mark, negative 5. Negative 5 on this side is negative 5, equals negative 5. Sure enough, that point is the solution for this system of equations, the red and the green system of equations. So again, that's how we confirm that if we get an x and y solution, that would be a solution to our system of equations. Does that point satisfy both lines? It does. So how about point 0.04? You know what? It's pretty close to 3.1. Well, not really, to be honest with you, but it could be a solution that you come up with after you do a couple manipulations on our data. Is it on the red line, 0 plus 4, x plus y equals 4, 0 plus 4 equals 4? Yeah, and the red line, sure enough, it does check out with the red line. With the green line, does it match? Is it on that line? Negative 2x plus y equals negative 5 is what we start with. And then we substitute in for x, negative 2 times 0, plus y is 4, equals, with a question mark, negative 5. 2 times 0 is 0, so what's left is 4. 4 equals, with a question mark, negative 5. No, this is not a solution. 0.4 is not a solution to the red and green system of equations. So there's the way that we would, I guess, check and double check to make sure that a solution is actually a solution to a system of equations.